Hello everyone. So today we're gonna discuss and have an interview with Akash. So I have two questions with him, and I will be giving the questions on him in the chat, and let's see how he will go through all the questions. So I will be sending the question to you on the chat, so you'll look it there. Okay.
Okay.
There's a chat button on the top. Yeah, the next button on.
Okay. 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 So, given an M cross and 2D grid map of ones and zeros, one is land and zeros is one. Return the number of islands. Okay. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are not surrounded by water. Okay. So,
Can you tell me in the first example what is an Iceland? Like, can you tell me?
what is the island? Okay. So, we have to find the number of islands. So,
The connected
the one
ones.
which is forming with ones,
Yeah. Okay.
and it is only one.
Okay.
And in the second example, one is this 4 1,
Okay.
and other is this,
Okay.
and the third is this.
Okay. So,
So,
how will go about this question? Solving this question.
So here we have given a 2D matrix and there are 1 and 0s. So I guess we can perform BFS or DFS on like every element when we found one, and check how many islands are there, and as we process every ones we mark them visited.
Yeah, that's correct. Okay.
So
Can you code it out?
okay.
Okay.
So, should I use BFS or DFS or
Anything you want. You can code it with anything.
Okay, so I think BFS would be good. So first of all, let me take the size, and it's an M cross N. Okay. So N is for number of rows, so grid
Okay.
dot size, and M is for number of columns.
Okay.
It is grid of 0 dot size.
Okay.
Now we will make a visited vector array,
Okay.
and let name it visited. Visit is, and number of rows would be n, and number of columns would be m, and all of them I have marked them initially 0.
Okay. Nice.
Okay. Now I will start traversing the array. Okay. So for and on reaching every element, I will check if this element is visited or not. So if it is if it is 1 or not, first of all I will check that.
Okay.
So first, if it is 1, then I will go there and also check that is it visited or not. So your I and J. So if it is not visited, then I will go in the array. So I will taking that. Now, what I can do, I can make a queue, and pair of queue, and push this element in the queue. So I comma J, and mark this element as visited.
Okay. Nice.
will start the BFS. Okay. And I will take the first element of the queue. Let it be P.
Okay.
And Q dot front. And I will pop this element now.
Okay. Nice.
And here we can maintain, we have to print the number of islands, so we can maintain a variable count, and count is equals to 0. And if we go in this, then we can increment the count, and this will be a final answer, so we can return this only. And now, and the constraints are 3 into 3, so 9, 12, 4. Okay, so we can also make an array for direction. X is equals to at 1, minus 1, 0, and 0, and into 5 is equals to 0, 0, 1, minus 1. Okay, so we will traverse through them to fall into k is equals to 0, k less than 4, k plus plus, and let L a equals to p dot first. We will increment every time, where we have to go left, right, up and down.
Okay.
So for that we will in the current position we will add the direction in which we have to go.
Okay, nice.
So we add the y
X of k.
and and p is equals to p dot second plus y of k. And now we will check that this position is out of the grid or not. So for that we will do if a is less than 0 and a can be greater than equals to n. If it is, then it will be outside. Similarly for b, p is 0 and p is greater than equals to n. And we can also check one more thing, that is this visited or not. So visited if this is the case, then we will continue. We won't take this. Otherwise, we will mark this visited and push it in the queue. So it will be, and we will also check one more thing, that is the grid are we on the line or not. So grid of A and B is going to if grid of A comma B is equals to 1. And we will make it a parenthesis out here too. So I think it's pretty much it. Okay.
So run it.
Okay. It is giving right output of the first section. I can check the second one too.
You just put the just remove the top brackets, the last letter of top.
Okay. Let me submit it.
Okay, nice.
Okay,
yeah, very good, very good. Okay, so the first question, so can you tell me the time complexity and the space complexity for this problem? you have written.
Okay, so for this space complexity, I think it will be n into m only, because I have just also created one more array for visited,
Mm-hmm.
and for the queue also it might take, but that will be in addition, so it will be m into n only.
Okay.
And for
Time?
the time complexity, I think it is also m into n, because I'm marking every element as visited and then checking it. So
Okay.
it will only check once only, or like twice. So it will be in addition to. So it will again be m into n only.
Nice. Very good. Very good. Okay. So, okay, this question is done. Let's move on to the next question. I will be sending you the question in the chat. So you can look it out.
Okay. So here we will be given a head of a linked list and remove the nth node from the end of the list and return its head. Could you do this in one pass? So
Okay, if you don't want to do it in one pass, you just have to solve it out. We'll talk about the one pass thing later. You just have to first
okay,
solve.
so we have to check it from the back. Okay, so this. Okay, so here one thing we can do is, if we don't have to do in one pass, so we can do one thing, that we traverse this linked list and take all its element and store in some vector array, and then remove.
Don't it's not advised to take out the elements and then store it out. You have to do it in the linked list only.
Okay, so
Like manipulating the point, you have to just switch out some pointers to like delete that out.
okay, so
Are you comfortable with like linked list?
okay, I can try this.
Yeah, you just try it out.
So here first, we will traverse the linked list and check what will be its size,
Okay, nice.
and then we can find the position which array to delete after knowing the position, the number of list,
Size.
number of nodes in the linked list.
Yeah.
And then we can like maintain one previous array, previous node and the current node,
Okay.
and then we can traverse it. And if we found the current head, then we can just make the previous element next position to the next position of the current head.
Yeah, correct.
And
correct.
then this node will be get deleted.
Okay, yeah, correct. So can you code it out also?
Okay, so
Try it out.
first I have to find the number of elements in the linked list. So
Yeah.
let's make it int is equals to size is equals to 0. And now, so now we will traverse the list, and if the current head is not equals to none, then we can go inside it. So this, and like we should not lose this position, so we will make another node. This the node star, and let's name it root is equal to head.
Okay, nice. Okay.
And if it is not null, then we can increment the size and make our head pointer head is equal to head dot next. So now we know the size and we also know the L. So which position to delete is would be, if we have 5 minus 2 is 3 plus 1. So it would be a size minus N plus 1.
Okay, nice.
Okay. So let's store that value in size only. Try to make another N. So size minus N plus, we have to delete this. Now we can make another node, previous, and let it be this allocated memory. And now
You have to make a previous and a current pointer.
and let make it add the current one, so it's root, and we'll go cover the same way. And it's and also make it another variable, count is equals to 0 to check it, and count plus plus. And if count is equals to size that we have to delete, then we can go inside, and if we don't, then it will be add is equals to add dot next, and previous also. So previous is equals to previous dot next,
Mm-hmm.
and I think that much is now in this. If it is the case, then we can make previous dot next is equals to head next. And one more thing we can do, if head is equals to null, and return that head only, and here I think we make it some string, should be it is not null, and similarly this. Okay, so, and if we want to return, then we can return only the root. And I think it should work.
There is okay, just run it out first. Run it out.
Okay, so okay, hi. So here what we can do is previous, instead of doing this, we can make it equals to head.
Yeah.
Okay.
One second.
This, yeah, totally. One minute. I think I make a mistake. One thing. If I delete the first node only and I'm returning the root value only, then it should give a wrong answer, I guess.
Check it.
Yeah. So if and I did something and do, and it would give a wrong answer. Yeah, so it would give a wrong answer. So what we can do is that we can make another like this. Let it be k, and let k is equals to previous, and here previous dot tag. Here what we can do is in previous next we can store head, and now previous is equals to head only. And now if we return k is equals to k of next and return is giving an error. I think I have to allocate memory to this too.
No, actually k is in the question what is given, k is given, or it is n given?
No, it's
Okay,
n.
okay.
So what I am doing is I think memory. Oh, one minute. I think this is the expected to. It is given to. Why it is given this? If you have to delete this only. Next. Next. Now, if this is the condition, then we can break it. Then it won't be. No, it still will give it.
Yeah.
Because we have not processed that. In this case, it's okay. And we can like keep else condition in this. And take out the break. And we can and yeah, head would be equals to head dot next. I think this should work now. Is it okay? Should I submit it?
Like there are 2-3 mistakes more, but first submit it out, then I will tell you. First, like
It got submitted.
yeah, it actually got submitted, but there are 2-3 like flaws there, like which I will tell you.
Okay.
So okay, so like if because I'm an interviewer, I can see 2-3 things more. So the first thing is you have to delete that node. You're not deleting it. You're just, where are you freeing the memory?
Oh. Okay. So for freeing the memory, what we can do? I think free head. Is it correct? I don't know this.
I think so. It is. I think so. It is delete. I think so. I think so. It is delete. Like don't write free. It's delete. I think so.
Free?
Yeah.
Okay.
Now submit. Now run it out. I think so. It will run.
Oh. I think it's 10. No, it's 5.
You're deleting the head.
Yeah, because that is what got deleted.
and then in the next line you are making head is equal to head dot next.
Oh yeah, 8. So
You can make some
another one
like
more node actually.
like you can make some node and store that address there, then do this head is equal to head dot next and then delete it out maybe.
So I delete this now. Yes, sure.
Like
Just give me
you are deleting the head node, like you're assuming that you have to have a pointer which is pointing at head node. You are deleting that head node and then you are taking that head node equal to next.
so if I don't make a pointer, then it should work, I guess.
No.
No,
No.
then it won't free the memory still.
Yeah.
So its head goes there. If I delete this head only, then what would happen?
So you are actually taking the the previous pointer to the next, make it equal to head dot next, which is fine. So the head is actually pointing to the pointer you want to delete, and then you are making head is equal to head dot next, which is so what this is actually for, like what this is actually for, like you're making the next pointer and then you're making head is equal to head dot, like what this line is for, head is equal to head dot next.
For like I have taken the else now, so for next occurrences, or next checking, not checking, but connecting the whole thing. No, that is not needed, I guess.
I don't
No,
know
that's not.
why this head is equal to head dot next is required. I don't know.
No, it's needed because I am returning the k value, right?
Okay.
So I have to make the whole link.
So the head is head dot, like previous net next is equal to head next. This is not making the link.
I think if I declare this here and make it here, then I think it's freeing the memory. And it should be star.
Yeah, that's nice. Okay, then now it's correct. So there is one more thing. Okay,
Okay.
let's assume that the question statement is not talking about the condition, but like there can be a condition such that the linked list size is, let's assume 5, and n is given to be, let's assume like it is given that second element from the back it is given now, but let's assume
Yeah.
I give some value 10th element from the back and the length is 5.
Yeah.
So
Then I have to check that if I can delete that or not.
yeah, so like uh, like whether you are like taking, like so you are taking your count and you are like, so let's assume that you are taking some number, so you're not talking about that case in which n can be a number which is not in the list size.
So if n is greater than the list size,
Then
then we cannot delete it. So that we can return if there is an option there.
so you are taking care of that, of like you're taking care of that condition I'm talking about that.
No, I'm not, because if that condition is there, then what should we return? There is nothing that
No,
we can return.
no. So
Then-
you just return out the originals, like original linked list. You don't, there is no node you have to delete out.
Okay, so that we can do if n is greater than size, then we can return head, no, root.
Yeah. No. Now it's correct. Okay. So you have to take care of, like, though this case is not in this problem, but you have to take care of that like case also, because like it can happen.
Yeah, okay.
Okay.
I
So
didn't take that into consideration because of the constraints.
Yeah. No problem, no problem. Okay, so now this is fine. Like this. So now you're finding out you're finding out first the length, and then you are finding out the element you have to delete from the start, and then you are deleting that element in this manner. Okay.
Yeah.
Okay. So can you think about a process in which you can do this or delete this in one pass? Like, can you think over this? Maybe you don't have to code it out, but just think over some possible like way.
So
It's just like the same question in which you have to find out the middle of a linked list in one pass. If you want to find out that if there is some linked list and you want to find out the middle of that in one pass, how you can find out?
so I'm thinking one thing. I don't know it's correct or not. Can I say?
Yeah, sure.
Like you give the hint of middle thing in that we use fast and slow pointer.
Yeah.
In this, we can take like if we want the second element, then we can make 2 pointers and make their difference like one. Like one is pointing to the first and second is second, and when the second pointer reaches the end, the first pointer would point to the like second last element.
Correct. So can you extend it to this logic?
What?
So can you extend it to this logic? Like if given you are given n equal to like some number, how can you find out the number?
Yeah, I guess I can do this. Should I code?
If you want, you'll do like you can make the difference between the 2 pointers equal to n. That's what you're telling me.
Yeah.
Okay. Yeah. That's actually correct. Okay. You don't actually need to code it out, but like I understand. So yeah, that's fine. Okay. So can you tell me the time complexity and space of this problem also?
Of the code that I wrote.
Yeah.
So if we talk about time complexity, then I'm traversing the linked list twice. So it will be 2 into n, the number of nodes in the linked list, and it's 2 into n, so it would be n only because it's in plus, and complexity will be of n, and where n is the number of nodes in the linked list.
Yeah. Okay.
And if I talk about like space complexity, then I'm using only like linked list nodes and making connection and no extra space. So for every node, I think it's a constant O1, I guess.
Correct. Okay. Nice. Cool. So like these are the two questions. Like you have answered them correctly. That's nice. Okay. That's nice.
Okay.
So just wait 1 minute. I'll pause the video out.